Let me quickly share my screen. Can you see it? Hello?
Yes, we can see it.
Yeah. So last time we did discussed about primary key and foreign key, but to give you a little bit of context who has not attended, I'll just recap. Imagine you were having student and marks information. Now the principal has decided to keep the student and marks information somewhere in the database or somewhere in the system. Suppose if I store those values directly in a flat file, it's not easy for me to retrieve because it's not easy. It's not going to be easy for me to search for that particular students and what all marks he has got, what all subjects he has enrolled for. So I am going to keep those in the table so that for me, selecting the values from for those particular students and corresponding subjects is easy for me. So now what I'm going to do is I, uh, I mean, instead of keeping all those values in different tables, as of now, let me go ahead and keep all the information in one place. I will tell you um, what is the disadvantage of doing it. So I have got the student ID, I have got the name, what all subjects he has enrolled for. Now there is a possibility nowadays in our schools, in Indian schools and US schools also, if you have seen, there are optional subjects or like um, there are subjects which people can opt for, which kids can opt for, right? Not all the subjects are there are first language, there are second language, there are third languages in the school where they have the information to change the subject if they want to. So suppose if I am not taking Telugu for my daughter, I am opting her for French, and there are kids who has not taken Hindi but they have taken Telugu, right? So if I store the values like this, having the student details and the subjects information together with the marks, I may end up having missing values here, like null values, values which are not present for some of the students, right? You got it? Are you getting, or any question here?
All clear till now.
Yeah, yeah. So I don't want to design a table which will contain this missing value. Suppose if I thousands and thousands of students over the years, it will become lakhs, and I'm storing all the information of all the kids from the day one of my school. It unnecessary. It is going to occupy all these spaces, which is not holding any value. So this design doesn't look good to me. What I can do is I will. This is the same example. I am just showing it here that there are missing values. Or there could be any possibility where if I am storing the address of a student, then what I have to do is student ID, name, student address, its class, and then I will repeat this here. So my student and the marks information and the subjects information are in one place. I am deciding it to put it in three different tables. Now, how this is going to help me is I can have student data independently in a separate table. If I have any changes to that particular student, if I am adding a new particular student, suppose in this example, if a new person enrolls or new student enrolls as Smith, okay, he will be going in say 10th grade, sorry, 10th grade. But since he has just joined, the information for this will be empty for him. Okay. Again, I have got 10 more students for this school year for only 10th grade. I may have for 8th grade also, 9th grade also. So these rows are repeating, but all these informations are empty. So if I take this student information out of that particular table and create a new table altogether, it is going to help me keep the student information easily maintainable position where I can add and remove student as and when I need. Okay. There also I can do it, but then I will lose the marks information. So keeping student data in separate table, keeping subject information in a separate table, and then whatever I will talk about this. So subject table, I am just keeping what all subjects my school is having. Okay. Now, be it any number of student who is coming in and going out, I know this many teachers I need to teach in my school. Okay. And I'll be having a count also saying how many teachers I have for French and all. Now, how do I know which user or which student is opting for which subject and has got how much marks? So if I am saying, okay, Ellis, he was having maths, Hindi, French, computers, science, history, and Telugu. So I can directly say student number 1 has opted for subject ID 1 and his marks was this. Student ID 1 or student ID 2 has opted for subject number 1 and his marks was this. So I am not going to maintain the information which was empty here. There is no need to create those records here. We are just breaking up the table in such a way that we are going to follow the normalization concept of the database. Normalization says that we should, every row and column intersection should have an atomic value. The value should be 1. It cannot be more than 1 and it cannot be 0. So the first normal form is saying it should have some value and it cannot have multiple values. I could have done something like that, saying student ID number 1, Alice, class or grade 10, and I can create a subject column here. I can say maths, comma, Hindi, comma, French, comma, computers, comma, commerce, comma, arts, comma, science, like this. But that is not going to make any sense, because suppose in future, if I change or divide the math subject as mathematics 1 and mathematics 2, just like it has in Cambridge board. In CBSE, we have only one mathematics, but in Cambridge board, they have two mathematics exam, they have two science exams, they have two English exams. They are separating based on fiction, non-fiction, and other kind of subtopics. So I may not be able to change the subject information if I keep those values like that in that table. I may not be able to change the student information easily, and I may not be able to have a good hold of marks, because then I have a control of not having those empty values. I am just keeping the subjects which has been enrolled by the student, and I'm just keeping the marks which has been enrolled by those particular kids in those subjects. Now imagine, so this student ID is coming from this table, this subject ID is coming from this table. Okay, there are two separate tables which is actually holding the value for a student and subjects, and we are creating a separate table to keep the marks there. Okay, since the student ID is coming from this table, I cannot have one row as a student ID as 100, which is not present here at all. There is no student with a student ID exist in my school. So I cannot have a subject associated to it. I cannot have marks associated to it, obviously, right? So student ID, since it is helping me to uniquely identify records here in student table, two students cannot have one similar or same student ID, right? When you are going and writing an exam, you have got an enrollment number given by the school or by the university. So your ID will be unique to you. Student ID will be unique. So even though my school has 10 people named as Megha, but my student IDs for those all those Meghas will be different, correct? So here for this table, student ID is the key. For subject table, the subject ID is the key. You're getting my point, right? So primary key, it is nothing but a primary key, which is helping me to uniquely identify the records. I cannot have maths repeatedly. I mean, I can say maths 1 and maths 2, but both of them will have subject ID different. Got it?
Yeah.
Till now, clear, right?
Yeah, means every student has say a different ID and every subject has different ID.
Yeah. So every table in SQL is going to have a key with which you are going to search, right? At the end, you will say, okay, I want to, when the attendance happens in the class, teacher say roll number 1, roll number 2, roll number 3 only, right? For roll number 10, no two person can stand up and say, I am present. Similarly, when we are actually creating the tables in database, we actually create the key, which is helping us to uniquely identify one record from the other record. This is one record. This is another record. This is called as one row also. This is called as another row. So one set of record needs to be identified uniquely from the other set of record, which is done by IDs actually, or keys we can say. Now, since this student ID is going and sitting in the other table, and the subject ID is going and sitting in the other table, this becomes the foreign key, because they are the key from some other table. But when they comes to different table, they will become foreign key. I'll take a very simple example of daughter and daughter-in-law. I mean, this is not fitting so perfectly here, but you imagine one girl is a daughter of one family, and when they get married, they will go to some other family. They will not become daughter there. They will become daughter-in-law, right? So similarly, the same daughter or same student ID, when it goes and sits into different table, they becomes foreign to that table. That is why the key, the same key which is going and sitting in the other tables, becomes the foreign key. Now, what will be the primary key for this table? Can someone tell me? Primary key is the key which is helping me to uniquely identify. So I am saying student ID has enrolled the subject ID 1. Student ID 1 has enrolled for subject ID 1 with having marks 89. Can I have another record as a student ID 1 and subject 1 and say 100 marks? Is it possible?
No.
Yeah. So the combination of subject ID and the student ID becomes the primary key here. I cannot say that this is the student ID can become the primary key here, because the same student can have multiple subjects associated to it or opted for it. I can say student ID has taken subject 2, subject 3, and subject 4. So my 111 is getting repeated. Now I can say second student has taken subject as 1, even third student has taken subject 1. So you see your subject ID is also repeating. Here your student ID is getting repeated, but the combination of two cannot be repeated. It is not possible. Student ID Charlie has got marks in maths. First row as 89, and another row I can say student ID Charlie having maths marks as 100. This is not possible. This one. Okay. So the combination of two becomes the primary key here. They both are foreign key to this table. So the child or the foreign key is actually referencing the parent. So if I have not have 100 here, and if I try to enter 100 here, it should give me an error, because your primary key itself is actually not having that value. So child is referencing the parent key. The child is nothing but a foreign key. So your student ID is always going to be the same, having the same values here, or it can be null. Either it can be null or it should be having a value which is already present in this table. Otherwise, you are going to get an error. This is obvious. I cannot have marks for a subject for a student who doesn't have any student ID or any student record in my school, right? How can how can a student give exams in my school for and the student itself doesn't exist in my school? Got it? Any questions?
I have one, Megha.
Yeah.
Like, can we search in this manner, like subject ID 8
Mm-hmm.
and let's say marks is 90, right?
Mm-hmm.
So if we put just two, not a primary student ID, can we get results out of it?
In real scenarios, there is a possibility
Mhm.
I will delete this row. Okay. So what will
Yeah.
happen to this orphan records? So there are triggers which will go and actually make this value as null. So suppose it was the 50th student, and later point in time the 50th student for some reason is gone, or some customer. Okay, so for Amazon, you were the customer and this was the order table. You were having orders and you deleted the customer because customer itself asked that go ahead and delete all my information from your website. This is just called data privacy and right. Sorry, hello, can you guys hear me? Hello.
Yeah, we can hear you
Sorry, I
now.
got
We
dropped
can hear
actually.
you.
I got dropped. I'm so sorry. So let me share my screen again. And the meeting is again going to end maybe in 5 or 10 minutes. So I will share another invite because we did not discuss the next topic. If you guys have time, otherwise then we can take up in the next session. You can see my screen?
Yeah.
Yeah. So your question is, yeah, I can have null value here, but which is not going to be wrong, right? I mean, which is going to be wrong. So when you decide, when you say, okay, if for foreign keys, when you say, okay, if the parent record is getting deleted, go ahead and delete this record also. You got it? So when we create the foreign key, there are options to tell what needs to be done if the orphan records are present and the parents is gone. Did I answer your question, Amrita?
Yeah.
Yeah. So if the child is referencing parent, it always has to have the parent record there. I mean, the value, whatever is there present in the child record, the value should exist in the parent. So that is where in this picture you are saying is the value okay? It is asking to the parent because it is referencing it, right?
Yeah.
Okay. If another example quickly, if I take about I have kids table, the very first session we had, right? We were having kids information like you can say it as student also, you can say it as kids also. Suppose this is an orphanage and they wanted to keep information for all of the kids what they have in their orphanage. So sometimes they wanted to know who, I mean, to whom all or one kid is friend to. Suppose if the person, I mean, if the kid is not feeling well and feeling sad or something, so if they know that these people are their friend, they will make sure to keep those together for some activity so that they will actually have their mood changes. Okay. So I have the kids table here. Now, suppose if I want to store the friends information, one is actually a friend of second and third is a friend of say second and fifth. How do I store it? Any idea? So, I mean, this is one record. This is another record. I cannot repeat Smith information in front of Bob information here, right? Are you guys getting it? Is it too fast?
Yeah. No, no, all good.
All good, right? So what I will do is I will create a new friends table where I will say, okay, kids, this is the ID, kid ID. So I will say, okay, kid ID 1 and kid ID 2. So I will store it as friends table will have 1 comma 2, one record, then 1 comma 3, second record, then 1 comma 4. So we will say 1, 2, 1, 3, 1, and 4. So friends table is going to keep only this two information. One is the friend of second, third, and fourth. And second is the friend of fifth. So this kid ID 1 and kid ID 2 is actually a foreign key of this table, though the same, these two columns are belonging to the same ID column. So how do we create it? This two, kid ID 1 and kid ID 2 is referencing the same column of the parent table, though they are two separate columns. If you want to visualize, I can show you. Can you see something?
Yeah, it's the another screen.
Yeah. So
Yeah.
if you see, this is the kids table and this is the friends table. And in the friends table, we are saying we are creating the foreign key, but both of them are referencing the kids ID column. So how the data looks like? The kids there are three kids available. And in the friends table, I have 1, 2, 1, 3, and 2, 3. So if I want to see for 1, how many friends are there, I will say select a star from friends where kid ID equal to 1. So I just got 2 friends IDs, but I don't know uh, which are those two kids actually. So then what I did is select a star from kids where ID is in second and third. So I came to know, okay, Bob and Charlie is the friend of first kid ID, the one which is Alice. Or I can write a nested query also to give instead of writing two queries, I can write a nested query, but I'm not going to give or exhaust you guys with those queries. I just wanted to teach you the concept of foreign key. Again, kids table having kids information. Friends table is not having anything else other than the friends are just nothing but just the kids, right? So I will have first kid ID and its friends ID. And both of these IDs are actually referencing the main table ID. So we will actually cover this in more detail when we are going to learn about how do we create the tables, how do we create this keys. Why I have to tell about the primary and foreign keys, because we were working on some of the select queries where we are going to join, or we are going to learn the joins and we are going to write the inner queries. For that we wanted to learn about those queries. We wanted to know the concepts of primary key and foreign key. And why are we doing it? To make sure we keep the data in such a way that it is easily accessible later. So now if I would have keep this Bob friends just next to him, and Smith was here also and here also. So now Smith is changing his first name or last name, or maybe the girl got married and their last name got changed. So I have to go ahead and change in all the places wherever the friend information is there for that particular person. So it is not easy to maintain, right? If I have given references just like this, I have only Bob information present in one row. If I put the friends here, then I may have to keep the Smith information in another columns as well. So the maintenance is not easy if we do that. So we break the table so that querying is easier. We break the table to avoid the redundancy of data. We break the table to make sure we don't have any empty columns. So this is all the normalization concept. This is all, I mean, it's just the theory, but it's good to know. If you guys are if you guys are comfortable, I can cover up a next session on the whole data normalization, database normalization. There are multiple normal forms, 1NF, 2NF, 3NF. Nobody is going to ask you that. I mean, if you know how to write the queries, but if you know these forms, then it is easy for you to build up a database when you are going to create the database from scratch in future. So that is going to help when you will build up the whole new database altogether, as it is going to help you in creating the tables efficiently so that it can be easily maintainable by people. If even if you left the company, they can easily maintain these tables. Any questions there? So another example of that we can say is I have books information in my library, and I need to keep the borrower's information also. So if I keep those two together, like book ID, this title, author, genre, and publication year, and if I put the borrower name here, it is possible that I might be having multiple copies of the same book and multiple people borrowing that book. So as I said, row and intersection of columns should have an atomic value. I should not be having values, say A, comma, B, comma, C, comma. Now, suppose if I want to know the information of B, when the person has to borrow and when he has borrowed and when is the return date expected, how will I take it? I need to parse this and I have to actually remove these commas to and find it out the position where the B is and get the return date information in the third column. So it's not easy to query those tables having non-atomic values in the row and intersection of those columns. So this is row. This is column. I should not be having multiple values here. This is one normal form. Got it? So what I did is I kept the book information in one place. I kept the borrower information in different place. Borrower books is going to be a static table. Suppose it's a library, an old library, and I'm not acquiring new books. This is going to be a static table, is not going to grow until unless if I acquire a new book. But borrowers can be maybe millions and millions of borrowers from the day when the library started, right? So a book is separately clubbed into a separate table altogether, and is not going to it's not going to be growing even if my borrowers are growing. But if we kept this information together with books, then I don't know how we are going to manage. I mean, this keeps on going and going and going, and it's not easy to find out the borrower's date or expected return date. Got it? Another example, if I can take, is customers and orders. We all shop in Amazon, right? So we do have customer information and order information. Customer information once fed is fed, right? Until unless I am changing my phone number, address, or maybe the credit card information. But my orders are keep on going. Though that becomes the transactional data. It is going on going, and I can maybe for a day's transaction I will keep in that table, and then I will actually delete the table data and put it in the backup table. So for a particular day, I'm just keeping 1 day data and keeping the rest or past history data in separate table. You might have noticed when you're doing an HDFC statements download, if you're downloading the transaction, maybe your download statement year is beyond statement months, or year is beyond 1 year, then they will say, okay, it is going to take up time, and you come back to this page again and download it later. So if the transaction table is having like 4 months or 3 months of data, for them it is easy to directly go to the transaction table and give the mini statements or months of data. But if the transaction is beyond some period, then they will put it in some separate backup tables, and then the querying to those tables will be some agent's task, or maybe a scheduled job which will run every hour and find it out who has requested for the statement to be downloaded. And then after that, once the job is actually running, after it has completed, it will upload the statement there, and then after some time you will go to the net banking and download your statement there from, right? So they cannot keep millions of records in one table also. It's not easily maintainable. When you try to query it, it is going to take up time. When the rows are there, obviously, until unless you are writing queries efficiently, even if you write queries efficiently and there are millions of records, it's not easy to fetch the query result in just span of seconds, right? So there are many database practices which has been followed. The one which I said, that we will just create the backup of the past data in some other table, so that the main transactions, because usually, I mean, there are only few people throughout the day who will come for statements beyond 1 year, right? And there are majority of the people who are just seeing the mini statements for the current month or just the last transactions. So that is why people who are coming rarely can wait, but people who are actually using the system throughout the day for small things, they should not be allowed to wait. Got it? Any questions? So we will take up more primary key and foreign key examples in the next class. And since we have broken the tables, now if I wanted to know what books Bob has borrowed, I have to go to the books table and find out the title of it. By looking at the book ID, if I say Bob has borrowed book ID 1, it's not going to make sense, right? It should tell me which was the title of the book, who was the author, and maybe I'm just interested in the title and the author. But just by looking the ID, I don't know what he has borrowed. So I may be joining these two tables to get the information. Since I have broken this information in two tables, I have to do something extra to get the information quickly and easily and efficiently. Okay, so I'll wind up here. If you guys have any questions around it, if I was too fast today, let me know. If any more information is needed on the primary key and foreign key concepts, I can share some slides or content. And next class, we will do hands-on on these tables, whatever we discussed today. And Amrita, I'll share the last session recording. I was just editing it.
Yeah. And this session also, if you send, I joined little late.
It's okay. I will send that also.
Thanks, Megha.
Thank you. Bye-bye.